Okay, guys, hey, we are going to do lesson 10.1 today, which is polar coordinates and polar equations, which is kind of new, but it's really not hard. Okay, but it is several objectives, so it's going to take us a little bit longer. I got a little stylus today because I can write on my computer screen, so I'm going to see if this helps. We will see. Okay, so we have first, what is a polar coordinate? It's just where you have your r and your theta, so your radius and your angle. And you have three different cases. I need to be able to scroll up. So right here, this just means when r is positive, when r is negative, and when r is 0. So three different cases. There's I starred this right here because when r is negative, you plot it the opposite way. So I don't know if you can see, but right here, the point is right here. So when r is positive, you just find wherever the angle lies, and then your radius, the distance of the angle, the side of that angle is that long. But when r is negative, if you notice, the point is down here. So you graph it, but then your r does like a 180, basically. It goes all the way to the opposite side. So when r is negative, that's what it does. Okay, and then if r is equal to 0, then r lies on the pole regardless of the measure. So if you notice, r is the vertex down there, or it could just be on the axis or whatever. Okay, so it doesn't matter what the angle is, r is down there. So when it's positive, it's at the end of the angle. When it's negative, it's opposite of the angle. And then when it's 0, it's the vertex. So I did 3 examples for you down here. So, and this is on here, right here. This right here. Oops, sorry. Let me unclick it. This is here just to kind of remind you where your angles are, but I'm pretty sure y'all know that. Okay, so our first example right here, -4 and pi over 4. Y'all know pi over 4 lands in quadrant 1, right? But because it's -4, it's over here. And on the homeworks, you'll see they have a bunch of circles on there. So you would count 4 circles out. And that's where your point would be. It's multiple choice, and so you just got to pick the one that matches. Here's an example where it's negative. Remember, a negative angle, you count down. And if it's by 3, we do 3 and then 6. So 1 less 5 would be in quadrant 1. And because it's a positive 5 right here, it lands on the end of that angle. Okay, and then this one's an example of one that lands on the axis. -pi/2 is actually down here where I'm marking in blue. But because my 2 is negative, I had to do it at the top because it's always opposite. So I did a couple of examples. I hope that makes sense. I can't see it, but I'm going to send it to you in Snap. The first 5 questions are review. So this is actually like questions 6 to 11 or something like that, are just multiple choice, and you pick where it lands. So it's pretty easy. Okay, objective 2. Scroll down on these notes, is determine different representations. So over here on my notebook, I'll try to draw big so you can see it without me zooming in. But I don't remember, if I have a pi over 4 angle, I can have that angle. I could do the negative angle, right? So, sorry. Pi over 4 is the same thing as -7 pi over 4. They're called coterminal angles, right? Or we could keep going around in circles. So I could go all the way around 8 and then 1 more. It's also the same thing as 9 pi over 4. I could go around multiple times, right? So the same thing with polar coordinates. Okay, so there's 4 different ones they're going to ask you to find. I'm just going to go ahead and skip down here to the example. Okay, so the one I used was 1. So our radius is 1 and our angle is 5. So 5 pi over 4. So you're going to pick where it lies. This is just like objective 1. So just find 5 pi over 4 lands in quadrant 3, go one little circle out. Okay, well then it has several other answers that are the same. Several of the polar coordinates that could land right there. So they're going to ask you first when r is positive and your theta is negative. So what's the negative angle right there? Basically, you're just going to subtract 2 pi. So your r stays the same because r is already positive up here. Okay, and then you subtract 2 pi, or you know if you just count, this is negative 3 pi over 4. So that's the first one. Then they want when r is positive again and theta, this is 2 pi, it's greater than 2 pi, but less than 0. I think I wrote something wrong. It might look like that on there. I don't know. Okay, I kind of cut this one off so you can't see. But what this one is basically making a circle and then going back around. So what this says down here at the bottom is 5 pi over 4 plus 2 pi. Basically, you're just making another circle. And one is positive still, and you get 13. So the first one, you're subtracting 2 pi. The second one, you're adding 2 pi. And the last one, C, is the most confusing, okay? Because r is negative. So that means it's going to flip. So what angle would make it flip to be down here in the third quadrant? Okay, so first, just put a negative on the r, and then you add or subtract pi depending on where it lands. Okay, so mine was in quadrant 3, so I needed to find out what is this angle, the complete opposite of it. So for this one, I would be subtracting pi. So how do you know if you add or subtract pi? If it's in quadrants 1 or 2, you're going to add pi. But if it's in quadrants 3 or 4, you're going to subtract pi. Or you can literally do these equations, or I kind of just look at the picture. Whatever works best for you. So that's objective 2. At the end of this, I put another example of objective 2. You can, I emailed y'all these notes, and I'll go over it at the very end of the video again if you need another one. Okay? So let's scroll down here. Objective 3. Now this one is converting from polar to rectangular, and then they switch and do rectangular to polar. Okay, so they give us 3 and 7 pi over 4, and you're going to use these two equations right here. X is equal to r cosine theta, and y is equal to r sine theta. Okay, so r goes in both of them, 3. And then x is cosine. So what is cosine of 7 pi over 4? What is sine of 7 pi over 4? So I drew it. Remember, all students take calculus. It's in quadrant 4. So I knew cosine would be positive, sine's going to be negative. Then back to your perfect triangles. You know your pi over 4 triangle is 1, 1, square root of 2. So I knew mine, and I didn't write it, but it's 3 times 1 over square root of 2, which is 3 square root of 2, and it's positive because cosine is positive. This one is 3 times negative 1 over square root of 2, and I got negative 3 square root of 2. And then you just put them together. What's x and y as an ordered pair is how you're going to have to type it. 3 square root of 2 over 2 square root of 2. So that one's not too bad. Let me erase. Let me clear this and scroll. I'm like so close to the screen. Sorry, guys. Okay, so here's another example where it lands on the axis versus using one of your perfect triangles. Okay, so we've got negative 3 and 3 pi over 2. Okay, so r is negative 3 now, and then cosine of 3 pi over 2. Negative 3 sine of 3 pi over 2. So 3 pi over 2 lands down here. Remember, x is your cosine. Sorry, it's not writing. Y is your sine. So this one is negative 3 times 0 is 0. This one's negative 3 times negative 1, which is positive 3. So that's my ordered pair. So, I mean, it's just these 4 points right here. I think y'all remember them, right? 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So you can use those 4 points, or it's going to be one of your perfect triangles like this, for example. Okay, pretty easy, not bad. Hope that one makes sense. Let's go on to objective 4. So objective 4 is opposite, going from rectangular to polar. Now this one is split into two, I have it into 2 different examples. So this first one, if it lands on an axis. So if, that's why I wrote in up here, if x or y is 0, that means it's going to land on an axis. So, clear that off. Okay, and you can kind of read through this. What happens when y is 0? Whoops, sorry. What happens when y is 0 versus when x is 0, and so forth when it's negative. When a is positive is up here, when a is negative is down here. Okay, so I did 2 examples. First, when x is 0, then when y is 0. So first, plot it. Think about where it is. 0 and negative 3 is down here, right? So your r is going to be, the r is distance, it's radius. So how far are we going? We're going 3. R is 3. Okay, so then you just ask yourself, what is the theta right there? Well, it's 3 pi over 2. That easy. Okay, same thing over here. 4. Where does 1.40 land? On the x-axis. How far did it go? 1.4. So r is 1.4. And what is that angle? You have to go from 0 to 2 pi, where 2 pi is not included. So you would use 0 versus 2 pi. Okay, those are really easy. It gets, you got to use formulas if it doesn't land on one of the axes. So if your x or your y is not 0, you're going to have to use these formulas right here. So the next spot. So we have r is the square root of x squared plus y squared. That's Pythagorean theorem. Okay, and then you're also going to use to find theta, tangent of the reference angle. So if it's in a different quadrant, you're going to find what it is the absolute value of y over x. So those 2 formulas right there are important. So let's do one. Excuse me, guys. Okay, so right here, and some of it's cut off, but I'll tell you what it says. Okay, so our polar quadrant is -6 over 6, and in blue up here, you'll see I wrote it. So that would be, if we were going to plot it regularly, like in junior high, 9th grade, we would go -6, 6, and that's where it would land. So the first thing they're asking you to do is find r, x squared plus y squared, and take the square root of it. So -6 squared, 36, 6 squared, 36, 36 plus 36, 72. Simplify that out. Is 6 square root of 2. How did I do that if you don't remember? 32 is 2 times 36. Square root of 36 is 6, so I could take that out. Okay, where does it land? Well, we drew it up here. That's quadrant 2. Okay, what is the reference angle? So you're going to do y over x. So ours is 6, and I wrote mine backwards. It should have been 6 over -6, but you get the same thing as -1. Absolute value of that is 1. At what angle does tangent equal 1? Pi over 4. So my reference angle is pi over 4. Okay, then they're going to ask you to choose a formula. So I went ahead and wrote all 4 formulas right here. So we have quadrant 1 for quadrant 2, for quadrant 3, for quadrant 4. But depending on what quadrant you chose in part B, tells you what formula to pick. Okay, but I don't really use the formulas. I just pick my pi over 4 angle in quadrant 2. That's what I do. But part of the homeworks are going to ask you to pick the formulas, so you need to know these. Okay, so like right here, I know the pi over 4 angle in quadrant 2 right here is 3 pi over 4, but I did it using the formula anyway. So pi minus the reference angle was 3 pi over 4. And then, so part F is just putting it together, put it in the polar coordinate. This is your R, and this is your theta, right? So my R was 6 square root of 2 over 3 pi over 4, and you just type it as an ordered pair. Okay, so I hope that kind of makes sense. It's pretty easy. You just use your 2 formulas, and then part D, choose one of these formulas. Or, you know, you have to choose one of the formulas, but just count it, whatever way works best for you. Okay, objective 5. Why did it? There's a big gap right there when it scanned it in. Okay, objective 5. These are the 2 formulas you're going to be using. We're now converting equations. First, you'll go rectangular to polar, and then you'll go from polar to rectangular. Okay, and these are the last 2 objectives. This is a very long lesson, so I would work on it a little bit every day. Okay, so x is equal to r cosine theta, y is equal to r sine theta. That's what you're using, okay? So first, this is the problem they're going to give you, just a regular equation that you would see, algebra 2 or something. 9x minus 8y equals 8. You have to convert it to a polar equation. Well, x is r cosine theta, y, ooh, why did it do that? Undo. Okay, x is r cosine theta, y is r sine theta. So you just plug those in. Okay, well, both of them have an r in common, so I took it out. 9 cosine theta minus 8 sine theta equals 8. Well, all of those are numbers now, and I could solve for r. So to get r by itself, you have to divide all of that. So once you have r equals, you're done. That's your equation you would type in. So I know it looks a little funny, but it's just algebra. You're just rearranging. So I put several examples up here. I won't go through all of them. The one I put a double star on, I'm going to go through this one because it's the hardest. But like some of them are as easy as this. X equals 3. R cosine theta equals 3. Got to get r by itself, divide by cosine. Okay, some of them are squared right here. Okay, I put this one on here because I didn't write it, but that's the other formula you need to know is that r is equal to the square root of x squared plus y squared. Okay, or if I were to take the square root off, r squared equals x squared plus y squared. I know it's not showing up too good, but that's Pythagorean theorem. That's what you're using down here on this one right here. Okay, so x squared plus y squared is r squared. Okay, ignore the dividing by r. That's my algebra work. Equals negative 6. Y is r times sine theta. Well, I gotta get rid of this r right here. So divided by r on both sides. 2 of them divided by 1 of them is 1. And then I have negative 6 sine theta. So your goal is to pretty much get r by itself. Okay, so let's clear all of this. And let's do this last one that's starred because I came back, I saw a harder one. I wrote it on there. Okay, so this is the problem they give you. X plus 11 squared plus y squared equals 21. Okay, so replace your x and your y. So x is r cosine theta, y is r sine theta. Okay, so I actually, like this part right here, you had to FOIL out. Okay, so r cosine theta times r cosine theta is r squared cosine squared theta. Okay, and then we had 11 times r cosine theta twice. So 11 plus 11 is 22 r cosine theta. And then 11 times 11 is 121. So I FOILed that right there. I didn't write it on here because these are my notes. So you can write it out. You'll get it. Y'all are all smart enough to get that. Okay, and then down here, there's not a plus or minus. So you literally just distribute the 2. So you get r squared sine squared theta equals 121. Okay, so I rewrote this a little bit different. I put the r cosine theta and the r sine theta next to each other. And then the 22r cosine theta over here. equals 0. I know it looks like a 1, but it's supposed to equal 0. My computer cut it off. Okay, because we subtracted this 121 over, and 121 minus 121 is 0. Okay, so from here, right here, they both have r squared in common. So I took that out. And I get cosine squared theta plus sine squared theta is a Pythagorean identity. So those cancel and give me 1. So basically I have r squared now is equal to 22 r cosine theta equals 0. Okay, now these two have an r in common. Took it out. So we got r times r plus 22 cosine theta equals 0. So that's two different equations by the zero product property rule. Like if we were factoring, we get r equals 0, we don't need that one. Or r equals negative 22 cosine theta. Because r equals 0 means your radius is 0, which means you don't have a circle. That's why you don't need it. Okay, so then that. So this one is the hard one. Y'all are going to want to come back and look at this right here. You will have some like this. Okay, I sent you these notes. Go look at them. It's here on the video. Look at whatever time it is right now. Come back and look at this when you have one. Okay. So that's rectangular to polar. And then the last objective is polar to rectangular. Okay. So these are the 4 equations you will need for these, which you already know these. We already talked about all of them, really. So we were using that, we were just using that. Okay. And this is the one from earlier. It just doesn't have the absolute value because it's not talking about the reference angle. It's just the regular theta. Okay, so for these, this is what it gives you. Okay, well, anytime you see r cosine theta, you can just put an x, so that's 9x. Anytime you see r sine theta, you can put a y, that's 8y. So 9x plus 8y equals 10. That easy. Okay. And I just put several examples up here. And it does look like it cut a couple off. Let me grab my notes. And I could show y'all what those are. Okay. So I'm going to zoom in over here in just a second. Let me just talk through these. So right here, there's nothing I can do because it's not r sine theta or r cosine theta. So I can't rewrite them as r or x. So what you're going to do is when you get that, you're going to multiply the whole thing. All of it. I'm using the mouse, so it's ugly. All of it by r. Okay, well, what does that give me? R squared equals 8 r sine theta minus 3 r cosine theta. Now I can change them out. This is 8y, 8x. You'll see how I messed that up. I had to go back and fix it. And then r squared is x squared plus y squared. You don't have to move anything around. That's it. Okay. Here's another one. Like I don't have an r in there, so I have to multiply the whole thing by r. X squared plus y squared equals 12y. Okay, it cut these last two off. This one used the secant. So for this one first, I had to put in a sign, right? So 1 over sine, but I need the sign to be over here by the r so I can change it to a y. So multiply by sine on both sides. I got r sine theta equals 5, and now this is y. So my answer here is on the paper would be y equals, let me do it with this pen, so I'm trying to do it with the mouse, equals -5. Okay, I'm gonna stop the screen share for a second. Come to this, see if I can make it bigger. I guess not. I don't know how to do that. Okay, but hopefully y'all can see it. That's that one I just worked. Let's take my phone off. I'm doing this with my phone, by the way. Okay, so this one got cut off. So r equals 5. What do you do with that? Again, you can actually use a pen to multiply both sides by r. So we get r squared is equal to 5r. 5 times 5 is 25, and r squared is x squared plus y squared equals 25. just another example down here. They sometimes will give you theta equals something. Okay, well, that's when you use the tangent. Tangent of theta, pi over 4, is supposed to be y over x. Well, tangent of pi over 4 is 1. So 1 equals x over y, and you can multiply by x, right? So x equals y or y equals x. I think they put it as y equals maybe. That's why I rearranged it. But either one of those should work. Doesn't matter. Okay. So that's objective 6. And like I said, the last part of this, I'm going to just go back to screen share real quick. Give me a second. I told y'all that I would do an extra example at the end. So this is back to objective 2 where they had all those R's, just another example of that. And then I did another one of the hard examples of objective 5. So these are 2 of the harder problems. I just went ahead and added an extra example I'll talk through. But if you're good, you can go ahead, stop the video, and do your homework. Okay, so right here, objective 2. Let me come to annotate. Okay, so I got 2 and 11 pi over 6. Where does 11 pi over 6 land? In the 4th quadrant. Okay, that's just for us to know. Okay, so A, you plot it first, so that is A. You gotta pick it. Okay, R is positive, so it's still 2, but now theta is negative. If I went down right here, what is that angle? Negative pi over 6. Excuse me. Again, C, R's, and they could switch them up. Okay, so right here, R is negative, so I changed it to R over 2. And remember, if it's negative, it was supposed to land in the opposite quadrant over here. So what is the pi over 6 angle right here? 5 pi over 6. And then finally, they're saying R is positive again, so 2. What is it when it's between 2 and 4? So that means when it goes a full circle. So we go all the way around, full circle, and then another 11. Okay, so 12 plus 11, that's terrible drawing, sorry. But 12 pi over 6 plus 11 pi over 6 is 23 pi over 6. Okay, because I had to go a full circle and then the angle again. So that's objective 2. And one more if y'all need it from objective 5 where you have to factor it all out. Okay, so I had, this is my problem, x squared is equal to y plus 8 squared equals 64. So x squared is r squared cosine squared theta. This one, r plus sine theta plus 8 squared, you have to FOIL it out. So r squared sine squared. Okay, and then we get 8 times r sine squared twice. So that's plus 16 sine theta. And then 8 times 8 would be plus 64. Okay, that's just foiling that part. Okay, so I wrote that all out right here, but that's how I got it. Okay, so again, you take the r squared out, and the cosine plus the sine is 1. So that went away. I scratched out, I didn't even write it. Okay, and then I got the 16r squared. When I move the 64 over here, you got 0. Okay, take out an r, so we got r equals 0. Again, we don't need that one. And then r, if I added it over, I would get negative 16 sine theta is my answer. So I hope that helps. I hope y'all do good on this. This is due Thursday night at midnight, and your quiz will be Sunday night at midnight. So good luck. Y'all have a good day.